Hello everyone, this video is for week 7, topic 4, part 1, and our topic is graphing exponential functions, and this topic can be found on your modules on pages 101 to 104, and we will be discussing examples 1 and 2. For the lesson outline, we have graphs of f of x is equal to b raised to x if b is greater than 1 and b is between 0 and 1. We will be discussing also the domain, the range, intercepts, zeros, and asymptotes of an exponential function. So to start, the graph of an exponential function is a necessary tool in describing its behavior and characteristics through its intercepts, asymptotes, and zeros. A graph can also provide insights as to real-life situations that can be modeled by exponential functions. So let us start example number 1. Sketch the graph of f of x is equal to 2 raised to x. And for this particular example, 2, which is the value of your base, is greater than 1. Okay, so we will be solving for the value of f of x given the values of x, an integer value of x, or integral values of x from -4 to +3, but you can also give as many as the values of x since the domain of this function is a set of real numbers. So let us start with -4 as the value of x. We'll be solving for the value of f of x. So let us start with -4. So we have f of -4. So we have 2 raised to -4. So this time we have negative exponent, so we'll be applying the law of exponent. For a negative exponent, we have 1 over 2 raised to -4 is 1 over +4. Okay, so we have 2 raised to 4 is 16. So if your x is -4, the value of your f of x is 1 over 16. So let us proceed if our x is -3. So we have f of -3 is equal to 2 raised to -3. So we have the negative exponent. This will become 2 over 2 cubed, and 2 cubed is equal to 8. So 1 over 8. Okay, 1/8. So therefore, if our x is -3, the value of f of x is 1/8. Let us proceed if our x is -2. So we have f of -2. So this is equal to 2 raised to -2. And we have a negative exponent, 1 over 2 squared, and 2 squared is equal to 4. Okay, so if our x is -2, the f of x is 1/4. Next, if our x is -1, so we have f of -1 is equal to 2 raised to -1. So we have 1/2. Okay, so -1, 1/2. Next, if we have 0, so 2 raised to 0, we will be applying the law of exponent for exponent equal to 0. So any number raised to 0 is always equal to 1 except for the base 0. So 2 raised to 0 is equal to 1. Next, 2 raised to 1 is equal to 2. If your x is 2, 2 squared is 4. If your x is 3, then 2 cubed is 8. Okay? So let us now sketch the graph on the Cartesian plane. Okay, so let us start from the first point, negative 4 1 over 16. Okay, so that this is the point. Next we have negative 3 1 8. Next we have negative 2 1 4. Next we have negative 1 1 half. Next we have 0 1. Next we have 2 4. And the last point is 3 8. Okay, so this is our last point, negative 3 8. Okay, and therefore we will be connecting these points, and this would be our graph. Okay, so take a look at this graph. This graph is the graph of the function f of x is equal to 2 raised to x. Okay, so let us have some observations about this graph. So it can be observed that the function is defined for all values of x. So it means to say that there is no restriction for the value of x. So what does it mean? Okay, so it means to say that you can use any values of x. So for every value of x, there is a corresponding value of y. Okay, so if your x is 3, the value of y is 8, and so on. So if your x is 6, there is a corresponding value of y. As you can see, this is your graph. If we will be extending this infinitely, so for all the value of x, there is a corresponding value of y. Okay, so it means to say that for our domain of this function, this is a set of x such that x is an element of real number. Okay, so you can assign any values of x as long as this x is an element of real number. Next, it is strictly increasing. So what does it mean? So it means to say that as the value of x increases, so from negative 4, in our example, from negative to positive 3, so as the value of x increases, the value of y also increases. So we have from negative 4, this is your y. Your negative, if your x is negative 2, this is your y. If your x is 0, this is your y. And if your x is 3, this is your y. You have positive 8. So as the value of x increases, the value of y also increases. And we have attains only positive y values. So we cannot have value of y equal to 0. We cannot also have a negative value of y. And if you are looking at this graph, okay, so this graph does not cross the value of this line, in which the value of your y is 0, so it cannot cross your x-axis. And of course, we cannot have the part of your graph in this quadrant in which the value of your y is negative. So there is a limit. Okay, so your graph cannot cross this line. Okay, so as you can see, for all the values of x, all the values of y are greater than 0. Again, it cannot be 0, the value of y cannot be 0, and it cannot be negative. And therefore, the range of this function is a set of y such that, or a set of y element of real number such that y is greater than 0. Okay? Okay, so as x decreases without bound, a function approaches 0. Okay, so as x decreases, so from example from negative 3, negative 2, from positive 3 to 1, so as x decreases, the value of y approaches 0. Okay, so it approaches 0, and that this line, okay, that is the line y is equal to 0 is a horizontal asymptote. Okay, so this is a horizontal asymptote. This is the line being approached by the graph, but it will never intersect. Okay, so the equation of this line is y equals 0, and therefore this is the horizontal asymptote. Okay, so the horizontal asymptote is y equals 0, and that line is this broken line. Okay, so let us now proceed. So example number 2, sketch the graph of the function f of x is equal to 1/2 raised to x, and for this particular example your b is between 0 and 1. So in our example our b is 1/2. Okay, so we'll be solving for f of x given the integral values of x from negative 3 to positive 4. Okay, so let us start with f of negative 3 is equal to 1/2 raised to negative 3. So this is equal to 1 raised to negative 3 over 2 raised to negative 3. So we have a negative or negative exponent. So what shall we do? So we'll bring our 1 to the denominator and make our exponent positive. So this will become 1 cubed. And we will bring this denominator to the numerator. And 3 will become positive. Okay? So in short, 2 cubed is equal to, okay, we have 8 over 1 cube is 1, and therefore we will simplify this and our answer is 8. So if our x is negative 3, we have 8. Next, if our x is negative 2, so we have So we have 1/2 negative 2. So we have 1 raised to negative 2 over 2 raised to negative 2. So we have, applying the law of exponent, we have 2 squared, 1 squared, and this is equal to 2 squared is 2, 1 squared is 1, and therefore 2 divided by 1 is 2. Okay, so if our x is negative 2, I am sorry, it must be negative, it must be 2 squared is 4 over 1, and our final answer is 4. Okay, So therefore, if our x is negative 2, your y is positive 4. Next, we have if x is negative 1. So we have f of negative 1 is equal to 1/2 raised to negative 1. So we have 1 raised to negative 1 over 2 raised to negative 1. And then we have 2 raised to positive 1, 1 raised to positive 1. This is equal to 2. Okay, so therefore if our x is negative 1, we have positive 2. Next, if our x is 0, of course, applying the law of exponent, this is f of x is equal to 1. If our x is positive 1, so 1/2 raised to positive 1 is the number, which is 1/2. 1/2 raised to 2 or squared is 1 squared is 1, 2 squared is 4, so therefore 1 over 4 or 1/4. So when your x is 2, your f of x is 1/4. If your x is 3, 1 cube is 1, 2 cube is 8, so therefore 1/8. If your x is 4, 1 raised to 4 is 1, and 2 raised to 4 is 16. So when your x is 4, your f of x is 1 over 16. Now let us sketch the graph of this function. Okay, so we have the first point, negative 3, 8. So this is negative 3, 8. Next, we have negative 2, 4. This is the point. Negative 1, 2, 0, 1, 1, 1/2, 2, 1/4, and the last point we have 3, 1, 8. Okay, and therefore we will be connecting this graph. Okay, so this is the graph of the function 1/2 raised to x. Okay, so let us have our observation. It can be observed that the function is defined for all the values of x. So again, this is your graph. So it means to say that for any values of x, there is a corresponding value of y. So if you will be reflecting all these numbers from your x-axis to your graph, okay, so from negative 2, there is a corresponding value of y. Negative 3, we have there is a corresponding value of y. And if we will be extending this, all the values of these x-axis has a corresponding value of y. So therefore, there is no restriction, such that for the function f of x is equal to 1/2 raised to x, our domain is a set of x such that x is an element of real number. Okay, next, it is strictly decreasing. So it means to say that as the value of x increases, as the value use of x increases, the value of y also decreases. So for example, if our x is negative 3, your y is 8. And if we will be decreasing the value of x, so if x is negative 2, the value of your y is 4. So as the value of x increases, the value of y decreases. Okay, Next, attains only positive values of y. Okay, so if you can see, our graph is here. It will never cross your x-axis, and of course, since it will never cross, the value of your y can never be positive. It could also be never be equal to 0. So the values of your y is always greater than 0 or positive numbers. And therefore, for this function, our range is a set of y element of real numbers such that y is greater than 0. So as x increases without bound, the function approaches 0. So as the values of x increases, it approaches to the value of y, which is equal to 0, and that is the line y is equal to 0. This is the line y is equal to 0, is the horizontal asymptotes. Okay, so this is the line being approached by the graph but will never intersect. Okay, so your graph will never intersect this asymptote. Okay, so our horizontal asymptote is y is equal to 0, and this is the line. Okay, so let us have the properties of exponential functions. So the following properties of f of x is equal to 2 raised to x, where b is greater than 0 and b is not equal to 1, can be observed from the graph. So this is your graph. So it says the domain is a set of real number. Okay, so the domain is a set of real number. Next, the range is a set greater than 0. So y is greater than 0. So range is y element of R such that y is greater than 0. Letter C, it is a one-to-one function. So it satisfies the horizontal line test. So in your previous modules, it was discussed that a one-to-one function satisfies a horizontal line test. Okay, so what does it mean when we say horizontal line test? If we will be drawing any horizontal line to your graph, this horizontal line intersects your graph at exactly 1 point. Okay, so therefore, the graph of an exponential function satisfies the horizontal line test. Okay, next, the y-intercept is 1. So this is the graph of f of x is equal to raised to x, and this one is f of x is equal to 1/2 raised to x, and the y-intercept is 1. So both of the graphs intersect at your y-axis at 0, 1, and the value or the ordinate of this point is positive 1. So the coordinates of this point is 0, 1, and the y-ordinate is positive 1, and that is what you call the y-intercept. Again, the definition of y-intercept, it is the value of y when your x is 0. So for this point, the value of x is 0 because the coordinates of this point is 0, 1, and the value of y is 1, which is your y-intercept. Next, there is no x-intercept. Of course, this is your x-axis, and both of your graphs will never intersect your x-axis. Okay, so therefore it has no x-intercept. So again, the definition of x-intercept is it is the value of x when y is 0. Okay, and the last one, the horizontal asymptote, is the line y is equal to 0 or the x-axis. Okay, so the horizontal asymptote is this one. This is the line being approached by the two graphs, but these graphs will never intersect this line, and this line is what we call horizontal asymptote. And of course, the last one, there is no vertical asymptote. So for these functions, we have no vertical line being approached by these two graphs, but but uh, we have no restriction for the value of x. So it will uh, extend infinitely for all the values of x. There is always a value of y. So we have no vertical asymptote. Okay? Okay, so for this video, we have discussed the graph of an exponential function f of x is equal to b raised to x, where the values of x is greater than 0 or the value of x is between 0 and 1. And we have also discussed um, the domain, the range, the x-intercept, the y-intercept, and the asymptotes of these graphs. So thank you very much for listening. I hope you have learned uh, something out of this video tutorial.